number, something point something, we're going to make what's called a stem and leaf. Now before I start collecting data, let me just get some ballparks. What kind of numbers do you guys get?
5.6.
I heard a 5.
6.
Stem and leaf. Also sometimes called a stem plot, depending on where you're reading. Okay, so I heard a 5. Anybody below 5? We got some 4s? Alan, you got a 4? Anybody below 4? Okay, so 4 is a minimum. Anybody go 8 point something? Anybody above 8? So you're above 8, Nick? You're at a
9.9.
9.9? Anybody above 9? Beautiful. So our range of values in the first part of the number is 4 to 9. Those we're going to call the stems. We're going to call those bad boys the stems, which in this case are the whole number part. The stem doesn't have to be the whole number part. In this case, though, because 4, 5, 6, 7, 8, 9, there's only 6 numbers there, what you're looking for in a stem and leaf is for one characteristic of the number to be extraordinarily tightly described, and the other one can be as widely described as it needs, and you'll see why that's helpful here. So 4, 5, 6, 7, 8, 9. Now the leaves, in this case, are going to be the decimal part. And these could be, in this case it's decimal because we have, 4 point something, 5 point something, 6 point something. So just shout them out now. Where are my 4s? Alan, you were a 4. 4.7. 4.7, thank you, sir. Put 0.7 there. Anybody else 4s?
0.3.
0.3s. Beautiful. Thank you, Haley. Points for 4s? 5s. Linda, point.
2.
0.2. Carly, point.
0.6.
0.6. Any other 5s? Just count them out.
0.6.
0.6. 0.6. Now, the important thing here is make sure that you space them properly, because you don't want to create skew by smushing down one particular. This is going to look like a histogram at the end, but you want to make sure that they're occupying the same space each time. Any other 5s I didn't get? 5.
0.3.
0.3, beautiful. 6s?
0.2.
0.2, I heard a 0.2, I heard a 0.4.
0.2.
0.2, 0.3.
0.5.
0.5. 0.5 again? Love it. 7s? 0.3.
0.3.
0.3. 0.2. That's all? 8s? 0.2.
0.5.
0.5. Beautiful. Okay, and Nick, you were 9.9?
Yeah, 9.9.
9.9. Any other 9s? That's a beautiful distribution.
So 6s are high, it seems like.
And then here's the beautiful thing. What we can do is, can you see the histogram? If you can't, turn your head 90 degrees to the right. Here it is. You don't have to draw this, but there's your histogram, yeah? Yeah, sorry, Southern California on it. Like, totally. So there's your, it's histogrammy in that way. This is really nice when whatever data you're collecting is really, really closely related in one way, say a bunch of 10s and 20s, or a bunch of 10s, 20s, and 30s, but then you've got 10 number possibilities for the second digit, 0 through 9. It's really nice to collect it in this way because it saves you having to write the stem over and over and over again. And a lot of times software packages will automatically collect this for you too in this way. Excel doesn't, but others do. Yeah, so what would you say on average we said as far as how many letters these words had? Like 6.5, I'm thinking. Most of them were 6s, and in between 6 and 7 is where all these things lie, right? So I'd say 6.5 letters. You know what the actual average is? 4.
Oh, wow.
Because, and this is where bias comes in. Think about how many words up there only have 1 and 2 letters in them. I, it, that's not L. I, my, by, he. Lots and lots of little words with 1 and 2, but our eyes aren't drawn to that, are they? Our eyes are drawn to the bigger ones. And I intentionally loaded that by showing you 3 big words in the beginning, didn't I? Dedicated,
Yeah.
refused, slashed, whatever the hell I showed you the first time. Did a bastard move on my part. All right, let's do one more of these generating our own data. And then we'll switch it over, and I want to show you some other stuff just to kind of round the day out, to kind of show you some interesting other ways to show data that aren't traditional. I'm going to need you to clear your minds again.